So far, the geometric objects that we have seen have been very simple. We have seen line segments, points, and things like that. But here we're going to talk about a particular geometric structure that is a complex structure, and that's called a subdivision. A subdivision is a decomposition of a plane into points, vertices, line segments, as well as faces. Let's say this region over here. Typically, subdivisions are stored in a structure known as a doubly connected edge list, and here we're going to look at how the details of this structure. As I said, that vertices, faces, and edges are the components of this, and the basic thing we want to achieve in this data structure is to support basic navigational operations. We want to move around in this structure in kind of an obvious and intuitive way. So the way this structure works is as follows. First of all, edges are stored in two copies. So you have a copy of edge on this side and a copy of edge on the other side. And on top of that, we also add the directions to edges. So the edges are directed. In other words, and also the copies are directed in the opposite order. So where this edge is in this way, the other edge is directed in the other way. And this direction is used in a very interesting way. It's in such a way that the edges are clockwise around the face. So here, when you look at this face, you have these three edges that form a clockwise order. And similarly, in this face, you also have a clockwise order of the edges. And that's why we need the edges to be in the opposite order. And in fact, it turns out that if you have this, like if you maintain this invariant that the edges are in the opposite order, then all the faces are clockwise, including this outside face. So I think that this outside face looks like in counterclockwise order, but that's because the face is to the outside. If we think of from the point of view of the outside face, this would actually look like a clockwise order. So that's basically the details of the structure. And on top of that, you have also a number of pointers. So every edge has a pointer to a face that it surrounds it. Remember that the faces have only one side here, because for every face, for every edge, we have added two sides. So for example, this side of the edge is adjacent to this face F2, so therefore it points to F2. The other edge points to F1. And on top of that, you have pointers to a twin of faces as well, so to twin of the edges. So each edge points to the other edge that goes in the other direction using this dot twin pointer. Okay. So in other words, you can think of an edge as having four pointers. You point to your twin. So for example, this edge points to that edge with the twin. You point to the face that surrounds you, and you point to your starting vertex, and you point to your end vertex. So that counts up to 4 pointers for every edge. Okay, well, that's the picture. But on top of that, you also need additional pointers. But that's because to maintain the clockwise ordering of the edges around the face, we also need to have them essentially in a circular linked list. You have the next and the previous that point to the previous in your linked list. And on top of that, those are the pointers for your edges. For the faces, we only need very simple pointers. You can have, for every face, you pick one edge and you point to that. Let's say face.edge. Since the faces could have a lot of, or unbounded number of, or let's say unspecified number of edges surrounding them, it's not feasible to have a face point to all of it. But if you point to just one edge, then we can, by this navigating the linked list, we can find all the edges surrounding this face anyways. So it's sufficient just to point to one edge. Okay, and with this, we're done describing this structure. So basically, to summarize, you have this picture over here that specifies how the edges are oriented. And you have this picture that shows how the faces point, what each face points to. And on top of that, you have this picture for the faces. Sorry, this was for the edges and this for the faces. And for vertices, again, you have vertex.edge. You just point one edge surrounding that vertex. We're going to look at these exercises in the exercise class, I'll just skip this part of the lecture.